to be looking at our pizza pictures for our fractions. I like to look at it just to make sure everybody's on the same page and understanding what's happening here. So in this particular case, Nathan ate 10 pieces of pizza. You can count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He ate 10 pieces of pizza. And Shayla ate 4 pieces of pizza. Together, Nathan and Shayla ate 14 pieces of pizza. Okay? I want you to discuss with your neighbor, is this true? Is that statement true? Together, Nathan and Shayla ate 14 pieces of pizza. And then discuss, is there anything misleading about that statement? So, your partner next to you, is it true and is it misleading? Are you questioning why Nathan didn't just eat that last piece of pizza?
Yeah, I'm questioning that. This is
yeah. It's like my kids leave like a teaspoon of cereal or something in the bottom of the box instead of just eating the rest of it. Just like. Okay, so is it true? Okay, raise your hand if you think it's true. Okay, raise your hand if you think it's false. Okay, we're kind of split here. I am on the side that this is a true statement. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Together, they technically did eat 10, 14 pieces.
But there's 5 slices.
So, but I will say that technically, this statement is true.
It's true that it doesn't have to get
But is it misleading?
Yes.
Yes. Because are Shayla's pieces of pizza the same size as Nathan's pieces of pizza? If Shayla ate 10 pieces of pizza this size, would she eat the same amount as Nathan? No. She would eat a whole pizza plus another 2 pieces, so another quarter of a pizza, right? That would be a lot of pizza to eat in one sitting. So, in this case, I'm going to go with a yes, but I'm going to put in parentheses, it is technically true. Because nothing about that statement specifies how big the pieces have to be, right? Now, if it said Nathan and Shayla ate 14 pieces of the same size pizza, then it would be false. But it doesn't say how big the pieces have to be. So I'm going to go with a yes technically there. But what's misleading is the pieces are not the same size. And that is the whole basis for why we cannot add fractions that have different denominators, right? So if I wrote a fraction for this pizza, what fraction of this pizza was eaten? Over here for Shayla, we could say half, right? We could call it half. Or if we're counting just the pieces, we could have called it 4/8, right? So that is 4/8. Over here for Nathan, what fraction of the pizza did he eat? 10 out of 11. 11 is a weird number of pieces to cut a pizza into. Because that'd be hard to do. You're never cutting all the way across the pizza. What is this insanity that I have taken off of the internet and put on this slide right here? Somebody is a madman that cut this pizza. skinny pieces. So we cannot add those together. We can't say 10 plus 4 is 14. That doesn't give us an accurate. That doesn't give us an accurate representation of what's actually happened there. So if we were going to talk about the total amount of pizzas that they ate together, we'd have to get common denominators to put that together, right? So it's going to be a little bit less than 1.5 pizzas that they ate all together. We could figure it out, but I'm not going to make you on that one. There. So, adding and subtracting fractions. To add and subtract fractions, you must have a common denominator. I got two blanks there, don't I? Alright, once you have a common denominator, you're going to add or subtract the numerators, depending on what signs you have there, and keep the denominator the same. Now let's pretend like Miss Hyatt does not know what she's doing. I'm going to pretend like I am one of my students, one of these students that has a panic attack at the sight of a fraction, right? So, if I am one of my students, I see students do this all the time. What have they done wrong? They added the denominator. Now, and if they do it that way, what answer do they get?
1/2.
Does that make any sense? 1/2 plus 1/2 equals 1/2. No. So I always tell students, because what I find is like you kind of know the rules, but you get them mixed up whenever adding, subtracting, multiplying, dividing are all put together. So maybe you multiplying, we just multiply straight across. Don't have to have common denominator. So then I see students also do that with adding, which you can't do. So if you're not sure, go back to the easiest fraction problem you know, 1/2 plus 1/2. 1/2 plus 1/2 does not equal 2/4, right? We know that that is not the case. So that means that process does not work for adding fractions. So, of course, on this, add the denominators, you get 2. Keep the denominator the same. I think I said denominator. Add the numerators, you get 2. Keep the denominator same, you also get 2. 2 divided by 2 is 1 here. So, on that one's fine, just write 1, but that's our process. All right, so we've just got a few examples that we're going to do here. So I've got 3/4 minus 5/12. We do not have common denominators, so it will always work. It will always work to do this. I could multiply this one by 12. I would hold off. I wouldn't write what I'm doing right now. I just want to show you something that will always work. So if you're stuck and can't figure it out, it will always work to do this. Multiply 4 by 12 and 12 by 4. But it's not always the easiest, because that'll give you a common denominator, but maybe not the lowest number that you could use. And if you do this, you're going to have bigger numbers you got to deal with. You'll have to reduce at the end. So it will always work to do that, but a better way is to ask yourself, is there anything I can multiply 4 by that will give me 12? 3. I could multiply by 3. So if I multiply the bottom by 3, I'm also going to multiply the top by 3. Because technically what you're doing there, you're saying 3/4 times 3/3. What is 3/3? 3/3 is 1. When you multiply something by 1, what does it do? It stays the same. It doesn't change it, right? So this makes it look different, but it doesn't change its value because we're really just multiplying by 1. So we've got 3 times 3 is 9. 4 times 3 is 12. Minus 5/12. So we've got our numerators. We need to subtract them. We'll get 4. Keep the denominator the same. And that will reduce. We could divide them both top and bottom. We could divide those by 4. And it will, in fact, give us 1/3 for our answer there. Very good. Okay, questions there? All right, 3. I've got 9/10 and 1/3. So I'm going to do the same thing. Is there anything I could multiply 10 by that would give me 3? Any whole numbers? I don't want to deal with fractions. That'd be a nightmare. Anything I can multiply 10 by to give me 3? Definitely not. All right. Anything I can multiply 3 by that'll give me 10? Nope. So in this case, it's not going to work to multiply just one of these fractions. We're going to have to multiply both of them. What is the least common denominator we can use here? 30. So I'm going to multiply this one by 3 to get 30. And the second fraction, I'm going to multiply it by 10 on top and bottom to get 30. So that will give me negative 27 over 30 minus 10 over 30. Now in this case, I've got negative, minus. So what am I going to do with those numerators? Do I add them or subtract them? They've got the same sign, because we're going to treat this negative right here like it goes with that 10. So they've got the same sign. We have same sign. We actually add, but we keep the sign, right? So 27 plus 10 will give us 37, but we're going to keep that negative because they're both negative there. And then just keep that denominator the same. I just prefer to you to leave improper fractions. You don't have to make it a mixed number because improper fractions will be more useful. Okay, example 4, we got 2/3 minus negative 3/4. First of all, I see a double negative right there. What happens with that? Both of those are going to become positive. So really, this is just 2/3 plus 3/4. Any number I can multiply 3 by to get 4? 4 by to get 3? No. So what should I use for my common denominator here? 12. So I can multiply this one by 4 to get 12. Multiply the second one by 3 to get 12. And so this will give me 8/12 plus 9/12. Add my numerators. I'll get 17. Keep the bottom the same. 17/12. That will not reduce, so we'll just leave that as our answer. Okay, questions?